Okay, these are our notes for 5.6. This is part 2. So notice now we're moving into solving some exponential equations. Now we solved exponential equations before. We did that by getting the bases the same and setting the exponents equal to one another. These are going to be problems where that is not possible. Where that is not possible, you are going to have to use logs to solve them. But these are still exponential equations because they're equations where the variable's in the exponent position. So hopefully you can look at this first problem and say, I'm going to have to factor that. How do I get it into a form that I can factor it? Well, we're going to rewrite this 9 to the x. We're going to rewrite the 9 as 3 squared. So it's going to be 3 to the 2x minus 3 to the x minus 6 is equal to 0. This is a form that we're going to be able to factor it in. Now watch how I factor this. Really, in the middle here, there's a 1 times 3 to the x. So let's think about that. So how am I going to break up 3 to the 2x? Well, it's going to be 3 to the 1x, 3 to the 1x. Remember, I'm unfoiling, and if you think about it, if I were to multiply these together, I would add the exponents. The bases, which are 3's, would not change, so that's where I would get the 3 to the 2x. Now I have to split up the negative 6 to get myself a negative 1. Well, that's obviously going to be negative 3 and positive 2. So these two binomials is how this polynomial factors. Now if I take each of these factors and set it equal to 0, here I'm going to get 3 to the x minus 3 equals 0, and 3 to the x plus 2 is equal to 0. Let's solve each one of these. Well, here I'd have 3 to the x equals 3. Well, that's obviously going to be x equals 1 because 3 to the first is equal to 3. If I go here and say 3 to the x equals negative 2, is there any power that I can raise x to that's going to get me a negative number? There is not, so that has no solution. So my only solution to this equation is going to be x equals 1. B, look at this. This is again an exponential equation, but notice you cannot get the bases the same. If this was, for example, a 9, I could make both the x's or both bases a 3 and I'd be good to go. But there's no way we can write these as a single base. When that happens, you have to use logs to solve. So what we're going to do, there's actually 2 ways to do this. I'm just going to show you one way though. So I'm going to take the common log of both sides. Now I'm going to use my property that says if I am taking the log of something being raised to a power, I bring that power down in front. Now to get the x alone, I'm simply going to divide by log 3. These will cancel. And I'm going to get x is equal to, and you'd pull out your calculator, which does common logs, and you would take the log of 7 divided by the log of 3. I've already done that. Rounding to the nearest hundredth, I got 1.77. Okay, if we look at C, notice what's being raised to the exponent here is not alone. So the first thing that we're going to do is to divide both sides by 5. These will cancel, and I'm left with 2 to the x equals, and what I did is I made this into a decimal. 3 divided by 5 is 0.6. It was just easier for calculator work. So now again, I cannot get these bases to be the same. So I'm going to take the log of both sides, use the property, the x comes down in front, get the x alone by dividing by log 2. These will cancel. x is equal to, take your calculator, do this into your calculator. When I did it, I got negative 0.74 when I rounded. Okay, for D, that's a much longer process, and quite honestly, you're not going to need to know it for your homework or for an exam, so we're not going to do D. We're kind of taking things and doing the essentials right now. So that one's done. All right, we're almost done with this section. So we've solved exponentials and logs again. Now the last thing that we want to do is we want to do it by using your graphing calculator. So like with any equation, and I've explained this, I actually explained it at the beginning of the course, you can solve any equation using the graphing calculator. All you have to do is take the left-hand side of the equation, put it in for y1, and take the right-hand side of the equation and put it in for y2. Graph those two graphs and see where the two lines cross using your intersect. And remembering you're solving for x, so you're only looking for the x of the point. So I'm going to go ahead and I'm going to do this problem in my grapher. So I'm going to go to the y equals, and then for y1, I'm going to plug in e to the x, so second ln x. So there's my e to the x, and then I'm just going to plug in negative x for y2. Hopefully everybody can see that. I'm going to press graph, and I'm going to watch them graph. So hopefully you can see as the two lines graphed, they're going to intersect about right here. So I'm going to do second trace. I'm going to find the intersection point. So I'm looking for 5. So again, if you use your right hand and left hand arrows, you can see that it's going to, this one is right now tracing the first graph. So I'm going to put it where it looks like they intersect and press enter. Now, if you did it now, it would trace the second graph, but again, your point should be fairly good. Press enter again. So this is what you get. So you can see, now again, this is the whole point where the two graphs intersect. I'm solving an equation for x, so I only want the x. So if I round this, it looks at like it's x equals negative 0.57. And that is how you solve for x using the grapher.